Okay, hi, good morning. Let's get started. I don't know why my thing's not going up there. Well, I don't know. There it goes. It just needs to go. Okay, anyway, sorry, it's early. Okay. Well, let's get to the computation, really the computation part of this class, this unit. Today, we're going to be talking about measures of center. That is things like mean, median, mode. Those are things that you've studied before. Refreshers needed, of course, but those are things that you've studied before. And we're also going to be talking about variance. And when we talk about variance, we talk about something called standard deviation. And I'm sure you've heard that phrase as well. So let's get started. Okay, let's start off with some definitions. The first definition being mean. I know everyone knows what a mean is. It's another word for an average. The mean of a set of values is the sum of all the data values divided by the number of data values in the set. Okay, so in other words, the average. Let's look at our first little example down here. Marcy's exam scores for her last math class were 79, 86, 82, and 94. Find the mean exam scores. Now, first, I want to show you that the symbol we're going to use for mean is called an X bar. Okay, and so X bar is equal to, and in this case, 79 plus 86 plus 82 plus 94 all over 4. And when you do that math there, excuse me, you get 6.2. All right, now I want you to note, sorry. My bad, looked at the absolute wrong thing. Good morning. Okay. Let me get a look here. This gives us 85.25. Now, I want to make a point here that's very, very important. Your solution from a calculation. So in other words, your statistic, remember we get a statistic from actually calculating, doing some kind of operation on data. So your statistic must be one decimal place more precise than your data. Okay, so that means, and let me write that. Your calculations. Ugh, can't write this morning. Gonna get straight marks. Let me get my act together. Hold on. Now I can't find my pen. Goodness. So your calculations must have one more decimal of, and this is what we call it, decimal of precision. Okay, and that's because there's a lot of rounding that happens, right? When you do your calculations, it's very rare that you have a um, a decimal that doesn't repeat or is not an infinite situation. So we're always rounding, right? So the idea is to kind of mitigate some of the errors that could come up from rounding by getting one more decimal of precision with every answer, hoping to encapsulate any of the errors that might happen from the rounding. Okay, so with that being said, the answer here is not 85.25, it is 85.3. So 85, my brain's moving faster than my hands today. So 85.3 is the average or the mean of the quizzes. All right. So let's keep on going. So there's mean and then there's median. Now median is often confusing. Median is the middle number in your list of data, right? And so if we say have a short list of 10 or 12, we can easily find where that middle value is if the list is put in order, done, no math involved. Say the list is 2000. Okay, that's going to be really tedious for you to find the 1000th spot in the middle and the 1001 spot in the middle. Okay, so there are some tricks and calculations. The thing that I need for you to know first off is that the data has to be in order from either smallest to largest or largest to smallest. Now, we almost always go smallest to largest. That's just the way that we typically do it. But if you wanted to go the other direction, the point being, as long as it's in some kind of order, ascending or descending, then you can use this trick. Okay. Now, the idea is that we're just trying to figure out the position in the list. Okay, so this trick here, this thing that I'm going to teach you, only gives you the position in the list where the median is. Okay, so this little calculation I'm going to talk about right here doesn't give you the answer, but it tells you where in the list the answer is going to be. So let's go over the rules real quick. So the rules say if the total number of data points is odd, then the median is the very center position. And if you even think about five numbers, like 1, 2, 3, 4, 5, if it's an odd list, this would be n is equal to 5, which is odd, right? If it's an odd list, then what this says is we can find n divided by 2 and round up to the next whole number. That's how we do this. We go n divided by 2 and round up to the next whole number. So here we would say to find the position, 5 divided by 2, which is equal to 2.5, and we round that up no matter what. So this is going to be the third position. Now we'll go to the 1, 2, third position, and we can say that 3 is the median. Now it's different, say, if we have odd number of terms. So let's say n is equal to 6. And I'll write my list here as 1, 2, 3, 4, 5, 6. That's our data points. I'm just making it easy. It could be any numbers there as long as they were in order. So what it says here for n is equal, if n is even, we take the average of the two middle values, n over 2 and n over 2 plus 1. And so still we find the positions 6 over 2, that's third. And this says that we take the third and the fourth. So now we need to average of the third and fourth data on the ordered list. Okay, and so 1, 2, 3, and 4. So here the median is going to be 3 plus 4 over 2, which is going to be 7.5. Yes, it is absolutely fine to have a decimal when you're looking at a median here. of whole numbers because you're finding the value in between that average. Sorry. Okay, let's keep going. So here's an example here, asking you to find the mean and the median of these quiz scores. And let me kind of leave this right here. First things first, whatever you do before you get started, I always count to see how many is in the list, right? So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers in the list. All right. And also, it doesn't matter what we're doing here. We're going to have the list in order. So I'm going to put the list in order here. And I've already done it. So it's 2, 4, 5, and 5, 6, 7, and 7, 8, and 8. And 10. Now, I like to write my list like this. That way, when I've got multiple numbers of the same value, I can see them really clearly. I can see how many there are. I'm not looking across vertically. A lot of times you can miscount if, say, there's, excuse me, 4 or 5. 1 or 2 or 3 is pretty easy to keep up with, but if it becomes many, many more, it's really a nice trick to list the repeats vertically. Okay. All right. So we've got our ordered list. Here's our ordered list. All right. We needed that. Okay. So let's do the mean here. And then I'll roll it up there for a second and get the mode. So let's do the mean. We don't really need to know the order or anything for the mean, but we're ready to go. And I'm going to use the calculator here, and we've got 10 numbers to add together, and it's completely up to you if you want to sum these all up and then divide it by, but I'm going to kind of be a little bit sophisticated. I'm going to do it all in one go. My words, I'm sorry. It's a little early. Okay, so I'm going to do it all in one go. I'm going to say 2 plus 4 plus, and watch this out, 5 times 2 plus 6 plus 7 times 2 plus 8 times 2 plus 10. And then I'm going to close that parenthesis because that's that whole top. If we were talking about writing that all out, that would be the whole top. Remember, we have to be careful with parentheses. Divided by 10 and enter. And our mean here is 6.2. Now, if that had given more decimal places, you would round it with the regular rules of rounding, 5 and up. We round up. Below 5, we round down, and that's how we deal with that. Now, when we start talking about the median, we can see that we have 10 scores. Yeah, 10 data points. So 10 divided by 2 gives us fifth. And because that gives us a whole number, we need the fifth and sixth averaged, because the even number of data, right? To find the very middle, we have to take the two middles and find the middle of the two middles. In other words, the average of the two middles. Okay. Now, we need the fifth and sixth. I want to come back over here to the list so you can see how this works. So we need the fifth number and the sixth number. So 1, 2, 3, 4, 5. The fifth number was 6. And we'll go back here and do the 1, 2, 3, 4, 5, sixth number. is 7. So 6 plus 7 divided by 2, that's 13 over 2, which is 6.5. Now you didn't have to show me all that work. If you knew what the number in between 6 and 7 is 6.5, that would be okay. But what do I expect to see? I expect to see this kind of stuff telling me which position and then what the answer is. And so we would now say median equals 6. Okay. All right, let's keep on going here. There we go. All right, now I told you mean, median, mode, and I know you've dealt with mean, median, mode before, and the mode is the value that comes up in the list the most. And let's take a look here. Is it necessary for it to be in order? No. Will you have already put it in order? Yes. So you might as well work off of your end ordered list. So I'm going to write that down again. 2, 4, 5, 5, 6, 7, 7, 8, 8, and 10. Now, if you look here and looking at what the definition says it's the data set that occurs most frequently. You can see here that there is no mode because there is not one data value that occurs more than any other. Okay, so I hope you can see that. Now, let me do an example. Let me just change this up. Okay, so if our quiz scores were 2, 4, 5, 5, 6, 7, 8, 8, 8, and 10, if this was our situation, not only would our mean change, our median would change, but also we would have a very clear mode here. And here we can see that the mode is equal to 8. So the mode is going to be whatever data point shows up the most. It's not a very useful statistic in general, but it is one that is used occasionally. What we're going to worry about mostly is means, medians, and what comes next, which is standard deviation. Okay, so let's look at how to do this off of a frequency table. All right, because I don't really want to, and I will. Your homework will come with long lists of data that you've got to plug through, that you've got to slog through. I did not give you nice, pretty frequency tables in your homework, okay? And you won't have nice, pretty frequency tables on your exam for this unit. You will have to be able to handle, organize the data, and get it all put together. That's part of it. All right, so let's find the mean, the median, and the mode here. And I want to do this a little bit out of order. I want to start off with the mode. And remember, the mode is the data value that occurs the most. And a frequency table is so awesome to do this with because what do we have? We have our category on the left and the frequency of that particular data point showing up on the right. So we can just look here very, very quickly and see that 18 is the mode because it occurred 8 times. The next closest was 20, which occurred 6 times. So that's that. We're good there. The next thing we need to do is let's figure out the median. And for the median, this is already in order, right? It's completely in order. But we do need to know what is in. So for the median, when you're given a frequency table, we need to know what's in, right? What's in? All right. How many are there? And how we figure that out is we add this up. So we have 10 and 8 is 18 and 4 is 22, 24, 26, 28, 29, 30. In is 30 here. So we're going to say 30 divided by 2 gives us the 15th and the 16th. Now, why do I know to go ahead and say 15th and 16th? Because if n is even, you can't find the middle, right? You can't find the middle of an even list. There's no one middle value that stands alone there. Okay, so you have to find the average of the two middle values, and that would happen to be the 15th and 16th. Now, how do we find the 15th and 16th value off of our table here? Very simply, we're going to count it. 1, 2, 3, 4, 5. I don't know why that's staying up. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 is happening here. So that is an 18. And if, let's count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So is 16. 15 and 16 are equal to 18. So we can say, without doing any math, that the median is equal to 18, because 18 plus 18 divided by 2 is 18. Okay. Sorry for the slurp. That tea is hot. Okay. And then finally, let's get our mean. And we're going to get the mean off of the calculator. And we're just going to add it in like we did before on the last example, but now we have something bigger. Do we have to do 0 times 2? We do not have to do 0 times 2. So we have 5 plus 12 plus 15 times 2 of those plus 16 times 2 of those plus 17 times 4 of those. Oh, I forgot to put my parentheses in there. Let me go do it real quick. If you forget something, you can insert. Now, one thing I need to teach you about this calculator is if you want to do anything written in blue, do you see how we have white, blue, and green on some of these buttons, but most of the buttons have white and blue. If you want to do anything in blue, you have to hit the blue button first. That toggles it to being able to insert. Okay. So we have the 17 times 4. Let me get my cursor back over here. I guess I'm going to have to do it this way. Okay, 17 times 4 plus 18 times 8 plus 19 times 4 plus 20 times 6, close, divided by, and how many scores total are there? 30. We added up the frequencies to find out what n was. And this is going to give us our mean at 16.23 repeats. Now we want to go 1 degree more accurate, 1 decimal place more accurate than the data we were given. We were given whole numbers. The scores of these quizzes were whole numbers. So our mean is going to be 16.2 because that 3 does not round up that 2. Awesome? Okay. Now, do not wait until the end to start working on this homework. None of this homework is particularly difficult, but it is very time consuming. And the only way for you to be effective with this is to practice. Okay, so let's talk about the measures of central tendency. Consider these sets of quiz scores, okay? Say one section of my class got all fives on their quiz. Another section, half of the class got zero, and the other half of the class got tens. And then another section, we had three fours, four fives, and three sixes. And if you take the mean of all of these three situations, the means are going to be exactly the same. But if you notice that doesn't tell the story, right? There's the story of everyone gets the same answer. There's the story of everyone's got a nice spread. And then there's the we get it or we don't get it. So you have to have other ways to, um, analyze data and see if we can understand what's going on through there. So that's where we come along with the standard deviation. And part of the deal is and we've talked about the range. We talked about the range in our last lecture when we were setting up those class intervals for the histograms. We talked about the range, which is the difference from the highest data point minus the lowest data point. So I don't know why I threw that in there, but it's there. Oh, why is this going the wrong way? All right, let's get to standard deviation. Okay, so the standard deviation is the measure of the variation of each data point from the mean. Okay, so we figure out what the mean of the whole banana, all the data, we figure out what that mean is. And then what the standard deviation tells us is how how does the data vary from the average? Basically, how will the data spread out? Standard deviation has the exact same units as the original data. So if we were measuring in weight, the standard deviation is going to be in pounds or grams. If we're talking about length, it's going to be in meters or inches, whatever. And also, just like the mean and being shown kind of here, it is susceptible to outliers and crazy data points and stuff like that. It can highly influence it, just like it would influence the mean. Okay, here are the steps to compute a standard deviation, and it's very methodical. It's going to look like, what in the hell is she asking me to do here? Okay, it's going to look like it is very crazy, but it really isn't crazy. It really isn't very crazy. It's very straightforward. And if you take a deep breath, right, and you just accept here and let me show you how to do this without any stress, then it's not going to be too terrible. All right. So the first thing we do is we find the deviation of each data from the mean. So first we have to find the mean. And then we subtract the mean from every single data point. Yes, this is tedious as heck. Okay. Then we square each of those individual differences that we found. We square that and then we sum all of those up. And then we throw them underneath a crazy square root symbol and we divide it under the square root by the total number of data points minus 1 because we're not dealing with an entire population. We won't be dealing with an entire population at all. As I noted earlier in this unit, that it is an impossibility for us to collect data off of an entire population. The symbol for standard deviation, as the symbol for the mean is a little x with a bar over it, the symbol for standard deviation is a lowercase s. Okay, y'all hold on. Don't freak out. This is the little table that I like to use so I can keep my thoughts organized when I'm doing standard deviation. And so I want you to be sure that you understand all these little pieces and parts here. So why is it doing that? So this is the data points. X, right? Each data point is an X. This is the mean. You see that X bar? That means it's the mean. This is the difference. This is the data minus the mean. And then this is the data minus the mean. So what you got in the last column and that crap squared. Okay, so no numbers here will be negative. If you get a negative number, you've done your square wrong on your calculator, okay? When you square a number, that means that number times itself, and two negative numbers multiplied to each other are going to be positive all the time. This is one of those things that you need to understand what's going on behind the scenes so you don't accidentally tell me that it's a negative number, or you don't add negative numbers into this, or you don't give me a negative number for a standard deviation. Standard deviations are always going to be positive. It is going to describe to me the variation, the distance variation basically of every data point to its mean. Okay? All right, so this is this information. This is the table that I use. You're welcome to use something different if you want, but I expect to see this. If you plug all your data points into the calculator, listen to me very carefully. If you plug all of your data points into the calculator and use the calculator's operations to give me the answer of the mean, I will not give you any points. I will say that again. I will not give you any points if you do not go through the process here in finding the standard deviation. If you use your calculator and you show me no work, I will give you no points. All right. It's super important that, and I understand you have calculators that can do this, but it is more important that you learn how to follow through on something like this. Start at the beginning and get it all the way to the end, because it's multiple steps, and that is very, very important for your brain. Sorry. Okay, so let's get started here. So the first thing we do is we write in all of our data points. So, and these are our data points. These are the prices of the 5 peanut butter jars. Okay, so I have $3.29. I have $3.59. I have $3.75. I have $3.79, and I have $3.99. And so we need to find our mean. All right, let's do that there. So X bar is equal to, and I've already done that work, but I know you know how to do that work. And the mean when you do the math is 3.682. Now notice I go out 3 decimal places because the price here was only 2 decimal places. Okay, we're increasing the precision of the number to make up for the rounding errors that will occur no matter what. Okay, so now we're just going to go through here and we're going to write our mean down on every single one of these. It's going to be the same number, because the mean is the same no matter what. Okay, now the next row here, that's the data minus the mean. So this is going to be 3.29 minus 3.682. We're going to figure out that number. And we'll go along here. So this is actually the next one. If we do that math, we're going to get negative 0.092. When we do that math here, we get 0.068. Please be very careful here. Just being off by a little digit will mess up your whole problem. You will not have the right answer. And if you do not show me your work so I can see where you went wrong, then I can't give you any points. Okay? So it's really important that you show me all of your work here. 0.108 and 0.308. Now, when we square all these numbers, so this was negative 0.392, and I squared it, and the answer I got is 0.1537. And so I'm going to square all of these. This one is going to give me 0.0085. I like to line my crap up real nice when I'm adding together a whole bunch of long numbers that could get me in trouble. So yes, this is extremely tedious. Every little step, very, very tedious. There's only like 5 or 6 data sets for you to do this work on. And, you know, there are a lot more than 5. Okay, so there's going to be 2 homeworks that are going to deal with standard deviation. The first homework that you'll deal with is going to ask you to find mean, median, mode. For the 2.3 stuff, it's going to ask you to find mean, median, mode, and the standard deviation. And they're decent sized sets. You're going to use a pretty decent amount of paper when you do it, okay? The second homework from the section is going to be a little bit more like the questions that I'll ask you on a test. I can't ask you to synthesize a data list of 50 numbers on a test because that's going to take you too much time. So the second homework, the 2.3 continued homework, is a little more like the data sets that you would see, say, on the quiz or the exam. Okay, now we have finished up the table. Now what? Well, let's look up here at our formula here. And at the very, very top of our formula, we have this thing, and it says the sum of the data point minus the mean squares. That's what that top is right there. And that is what we're going to get when we add these up, because notice what we've got here. This is the x minus x bar quantity squared. That's exactly what the top says here, except for it's got this crazy Greek letter, and that Greek letter means sum them all. In other words, add them all together. Okay, so when we add these all together here, we get 0.2733. Now let's pay attention. Let's pay attention to the other piece here. The other piece being the n minus 1. The n minus 1 lets us know that it is the 30, because that's how many, or no, n, 1, 2, 3, 4, 5. N minus 1 is 5 minus 1. N being the number of data points. And in this case, we have 5. So we're going to finish this up by saying S is equal to the square root of, and be careful with your square root because notice this n minus 1 is underneath the square root, so you have to be careful here. We've got the 0.2733 over 5 minus 1 is 4. Now let's plug this into the calculator here. And I want you to note how many decimal places the answer needs to be. We need 3 decimal places. Because the data that we worked with was only 2 decimal places. So we need 3 decimal places in this answer. Okay, let's get over here to our calculator here, and we need to do the square root. And you got to look around here, but if you see right here, in the shift of the to the power of 2 button is the square root button. And remember what I said a few minutes ago, anything that you want to do in blue, you have to hit this second key first. So go second, X, oh, see, didn't hit that second good enough. Second X squared, now I have a square root, yay. And we're going to go 0.2733 divided by 4. Notice all of that is underneath our square root, which is what we want. And then I'm going to use the arrow key because it's just my habit to get out of whatever function we're in. And then we can hit enter. And so we get 0.261. So we can say the standard deviation of the peanut butter jars is to, uh, there it is. I can't say that word. Like 26 cents in a thousandth? Anyway, you would just write it there. We wouldn't say it because it's no way to say money like that. It doesn't go out that far. Okay? All right. Okay. Here's a you do for you to do. Now, I do want you to ignore this. I meant to take this off of, I'm just going to scribble it out. That is just if we were given the entire population, and I'm sure not going to do that this semester. Okay. So this is a you do for you. I'm going to give, I don't know, about 5 minutes here for you to work on this. I know if I do not give dead time, you're not going to work on it. So you can fast forward through this dead time and not practice, or you can go ahead and try to work on it here, and I'll be back. I will write the formula for standard deviation here. Sure, why I couldn't keep all that. Why is it going away? Okay. I used something different. I used a pencil, and I guess it, oh, it automatically converted my handwriting to text, and it's all over here. I do not know what that is. That is brand new and not what I tried to do. Let me just give it to you right here. I hope you're working on it. The 5 minutes are going. What do you have to do? You have to find the mean before you can compute the table. And while we're quietly working on this example, I want to give you today's silly phrase. Today's silly phrase is that otters, the really cute things that swim in the river, otters make the best bakers. Otters make the best, oh, let me be very clear. Otters make the best professional bakers. So that is the phrase. Otters make the best professional bakers. Okay, I'm going to give you a couple more minutes to keep on working on this. This is the last example. It doesn't really do me any good to do a whole bunch of examples. The truth of the matter is you can replay this lecture. You can go back and look at it. You can figure out what I did and or where you don't understand. And then, of course, as always, you can reach out to me. I'll be more than happy to help you. And honestly, the mean guy is the thinnest uh, area. And I would suggest you do this on lined paper so you can keep all your columns straight. It's kind of hard like this, so I'm just going to kind of make this a table. I don't know why the whole table didn't populate on here, but I'm not worrying about it. We can work with it. Another minute or so. I'm going to start writing a couple of things in here. The mean, remember, has to go out 2 decimal places, and the mean will be the exact same for every one of the data points. So this is just always the same number. Now we'll do that math here. So that is this guy minus that guy, right? And when you do that, you get -5. Right? I'm just going to write in these values so you can check them yourself. And then remember, we're squaring these. Remember that these squares are never negative. Let me show you what I mean here while you're working on this. If we say you did this 15.2 minus 21.08 and hit enter, you got me that answer there. If you tried to take that to the power of 2, that's going to give you the nice positive answer. If you say, so that's me taking the whole answer to the power of 2, and let me just go ahead and write that down. And it needs to go out 3 decimal places, so this is going to be 34.574. Okay, now if you just said -5.88 squared, there's a difference here, so be careful. That's going to give you a negative answer now. That's because you didn't use parentheses and because the calculator will read that this negative as all by itself. It reads that as -1 times 5.88 squared. So up here, if you use the answer squared, it's going to capture that negative because that was part of the answer of the previous calculation, which is what I used. But if you just type it in there and square it, then you're going to get the negative. Now, that's okay if you do that, but you need to know when you square a number, it's positive. And as long as you don't write the negative down over here, you'll be in pretty good shape. Let me go ahead and write down the rest of these here. If you have any calculator problems, issues, questions, please send them my way. If you do that, then not only will you benefit from understanding what uh, you're having trouble with, but also that'll let me know that there's a problem out there and maybe I can address the entire class. In fact, I have 3 classes of this. So this lecture doesn't just go out to your section. This lecture goes out to all 3 of my sections. So there's about 100 of you right now taking my class. Okay. All right. So help out your fellow students. If you don't understand something, chances are really big, y'all, that there is somebody else in that 100 people pool that doesn't understand the same thing. So be the brave one, ask the questions so I can make sure that everyone has got a good shot at it. Okay, now we're ready to sum this up. When I sum this up, it is 109.386 is the sum here. And now we're ready to jump in there and do this standard deviation business. So S is equal to the square root of 109.386, right? That is this number that goes along with this symbol, and there's that number. Okay, that's how it all matches in and goes there. Divided by, and our n was 5, so this would be 5 minus 1 equals 4, so over 4, and then we're going to do the same thing here. We're going to go second square root 109.386 divided by 4. Get out of there and enter. And so our S is equal to, we need to go out 3 decimal places. So we got 5.2293. So it's going to be 5.229. And so we could say that the standard deviation of the time to complete the puzzle was, I think this is probably in minutes. Okay, so 5.229 minutes. Okay, y'all hang in there with the statistics. We have one more section. I will promise you that this particular section right here is the most intense of the sections. It is tedious. The work is tedious. So hang in there. We're almost done with this unit. The last stuff is pretty straightforward, pretty lovely. In the whole grand scheme of calculations of statistical centers of variances and things. So y'all just hang in there. I appreciate you. Hope you have a great day. And again, don't hesitate to reach out to me if you need any help or have any questions.